I like to help you homework a little bit. So this one is 1.3 transformation assignment. Let me go with a few problems here. Write g of x in terms of fx after performing the given transformation of a graph of fx. So what you are seeing, this one is g of f of x, given function f of x. And we are going to transform, depends on the instruction. In this case here, we said we are going to move this given function to the left 3 units. We have a reference point here, this one, this one, this one. We call reference of point. One of them is 3 and 0, 0 and 2, and negative 3 and 0. We are going to move this function only x, because when it says left 3 unit means x axis. So this reference point 3 minus 3 gives me 0. So we are moving to 0 right here. And 0 minus 3 gives you right here. Negative 3 minus, so negative 3, that's a given function, minus 3, moving to the left, so right here. When you move left and right, we do not change any y value. Y value stays same, which will be a 3. So this entire graph transformed to the left 3 units. So new transformed function notation is g of x. This is the new. Is we move inside x to the 3 unit. Like I said during the class, this one is always built in. So final function notation is x plus 3. Number 2, translate the graph of fx up 2 unit. Up 2 unit. That means we have to, there's a 3 reference point right here. But hang on, we do not need a reference. We do not need x reference point. We need y because up 2 unit. From the 3, 1, 2. My reference point move up. And then 0. This is negative 2 and 0. So 0 move 1, 2. My reference move. So this one moved up. So this new function g of x is entire function move up 2 unit. Translate graph of fx to the right 4 unit. Right representing means x on x move it. So this my reference point move to 1, 2, 3, 4. Negative 2 move to the right 1, 2, 3, 4. Does y value change it? Nope. Y value do not change it. Y value stays same because they did not talk about any y value. They said only we're gonna move x. So that's it. So we did new function is we move x to the right. That's it. X to the right. Remember, this is a built-in. So when you cover this one, we only see the positive 4. Translate graph f down 3 unit. Down 3 unit. That means only y value will change. So let's go. This one we move. This one is a 1, 2, 3. 3 down. So 3 unit, 2 down. So it will end up 0. This is 0 move to 1, 2, 3. I'm moving only reference point. 1, 1, 2, 3. This one, 1, 2, 3. So I have this 3 reference point. 1. X does not change it when move down, up and down. So my new function is I move original given function minus 3. Remember, as you see, when you move the y value up and down, if it's a down, down means negative, up means positive. But x value, when we talk about x value, left means, so from the x, this one is built in the negative move, so you end up x plus h. Okay. From the 5 was the next homework. Let's do horizontal. Stretch the graph horizontally by factor of 3. So horizontal means x value. My dual graph g of x is, okay, we're gonna group because since it's x, all the value be inside. Factor of 3. That means it will, factor of 3, it will stretch, change will be 1/3, affecting only 1/3 of x. Okay, so I'm stretching 3 times. So right here, 2 become 6, -2 become, but again, horizontal stretch doesn't affect the y value. So we are stretching horizontally. We are stretching horizontally. Okay. This one, vertically stretch means vertically stretch means that you are going to only move up. Y value change. Oops. Y value change. Vertically means y value will change and x value stays same. Compress graph horizontally. Compress graph horizontally. Compress graph horizontally. Which means that we are going to, from the given function to, we're gonna push in. We're gonna push in. Compress. So y value stays same. And it doesn't change. The parent function or a given function. So let's do factor of 3. So it will only, what factor of 1/3 means is y value gonna be, y value gonna be 3 times bigger because this is represent y. So when x is 1, it will be 3. When x is 2, it will be 6. Same thing. It will be shrink and it goes this way. Remember, horizontally compress. For example, if a horizontally compress means a parent function has m and it passes through the mm. This is fx. Okay? If we compress horizontally, that means nu will be divided by that factor. Okay, divided by the factor. So it's gonna be, a graph is gonna be compressed means its graph gonna be narrower and narrower when we talk about horizontal. Reflection, this one you can do. This will not be difficult either. Let's try with this one. Determine if function is an even or odd function, or neither. we know from the graph, even function means the function has excess of symmetry. Excess of symmetry. So there's a, when you fold it, it has to be, both sides has to be symmetric each other. And odd function means that when you flip it, if I flip it this way, this way, 90 degree, and then one more time, if you do from the origin, if you continue to flip it, then it comes back to where you are. It comes back to where you are, then it's going to be odd function. So I want you to flip it. I want you to flip it. And then the other way we can find it is that if even function, if you pick the negative number, that value has to be same as a positive number. Then it's even. So for example, let's look at this one. This odd function is the positive. When you pick the positive, it will be x minus 2 squared. If I put the negative x minus 2 squared, is this same? Is this and this are same? They're not same to me, right? X minus 2 squared is not same to negative x minus 2. It's not same. So is this even function? Nope. It's not even function. So that's how you're gonna do. This means x was a translate to left 4 units, right? Because fx minus negative 4, because minus, it has to be always built in. Okay, rest of them we are going to do during the class time, and I hope this will help you.